In this video, we're going to talk about some common number systems. So for example, if I were to say, hey, what are the counting numbers? You'd probably start with 1, 2, 3, 4, and keep counting, right? So those are the counting numbers, are also what is commonly known as the natural numbers. And if I were to write that out in set form, which we've talked about in a previous video, you can see I have set n, and this is kind of a fancy n right here with a double lined connecting piece there. That's just to indicate the natural numbers n. And in that set belongs to numbers 1, 2, 3, and then the dot, dot, dot means I continue infinitely, and I'm going to close that in with my brackets right here. So the set of natural numbers, or the counting numbers, is 1, 2, 3, so on and so forth. Okay, the integers, we're going to denote that with kind of a fancy Z there, and if you can see, it's very similar to the counting numbers, but now in this case, I'm also going to include 0, and I'm also going to include the negative versions of all of my counting numbers as well. And you can see here that I go infinitely in either direction. Those will be all of the integers. Now, what those, neither one of those sets contain are what we would call fractions or decimals. So now we're going to look at set Q, which are our rational numbers, and these are numbers that can be represented by a fraction in A over B, right? Where we're going to say A and B both belong to elements of Z, which means they're all integers, either positive or negative, and we're going to say B can't be 0, because if B is 0, in this case, we're representing a fraction, and that B is 0, we're going to have 0 in the denominator, which means that is an undefined number right there, okay? So a rational number is any number that can be represented by a fraction, okay? All right, the irrational numbers are going to be similar. It's going to be Q, and then we're going to have a superscriptive C right there. That is going to indicate the irrational numbers, and these are just numbers that are not rational. Okay, we're going to talk about here in a second about a good example of some irrational numbers would be the number pi. The next set of numbers is going to be called the set of real numbers, as indicated by this capital fancy R here. And these are all rational and irrational numbers put together. Or in another way to think about it, if I were to draw a number line, that would be any number that can be included on that number line. That includes decimals, repeating decimals, non-repeating decimals, whole numbers, negative numbers, and 0. They're all the real numbers. And in another set, the last set that we'll look at is called the set of complex numbers, also known as imaginary numbers, but we're going to use the capital fancy C here. And they're going to be written in the form A plus BI, where A and B are real numbers, right? They can be integers, they could be fractions, they could be decimals, they could be irrational numbers like pi, whatever it is, any number from that real number system. And then I, which is represented by the square root of -1. All right, so in this video, we're going to look at a couple different numbers. We're going to look at, for example, pi, and we're going to look at 0.3 repeated, right? So both of them are non-ending decimals, right? And I know that pi is approximately 3.14, and it goes on forever and never end. And because of this fact, that means I cannot write a number of two integers of a over b. This will not work. I cannot turn pi into a fraction. And so because of that fact, that makes this number irrational, right? The reason that pi is irrational is not because it's a non-ending, non-repeating decimal. It's because I cannot write it as a fraction. That's what makes pi irrational. Now, if you compare that to 0.3 repeated, right? It's a non-ending decimal, but it does repeat, which allows me to write it as a fraction, in this case 1/3. And because I can write it in a fraction, that is going to make this number rational. Okay, so again, the reason a number is irrational is can I write it in a fraction? If the answer to that is yes, then it makes it a rational number. If the answer to that question is no, I cannot write it as a fraction, that makes that number irrational. Okay, so remember that's very important that you use that particular wording. All right, complex numbers are I equals the square root of -1. Now, a square root of a number means what number times itself will give me the number underneath the radical, right? And so since there are no two numbers that I multiply together that they're exact same, for example, you might be thinking, okay, well, it's 1 times -1. That gives me -1, and those are the same. Well, 1 is not the same thing as -1, therefore I cannot take the square root of -1. And because of this fact, that makes this number imaginary or complex, which is why we use the symbol I. So now you may see something like this, I squared, which is the same thing as I times I, which is the same thing as the square root of -1 times the square root of -1, which can be rewritten as the square root of negative 1 squared. And when you get to this point, as you'll notice, the square and the square root are opposite operations of each other, which basically more or less cancel each other out, even though I don't like using the word cancel out, which leaves me with negative 1. So in this case, I know that I squared is equal to negative 1, right? You may see something like this, I to the third. Well, that's the same thing as I times I again, which is square root of negative 1 times itself 3 times. But now if I take these two, we've already just determined right back over here that we've already determined that square root of negative 1 times the square root of negative 1 is negative 1. So I can replace that with negative 1 here times the square root of negative 1. So that means this is the same thing as I. So I have I here, and then don't forget I have this negative out in front, so it is going to be negative I. So now negative I is the same thing as I to the third. And then we can do something similar in I to the fourth, which is, again, this here, which we know this to be negative 1. We know this to also be negative 1. And now I have negative 1 times negative 1, which is positive 1. So now I to the fourth is the same thing as 1. Now, we could go on and on. We could do I to the fifth, I to the sixth, seventh, 17th, whatever number it is. You just have to write it out, okay, like we did here, and then do all your simplification till you end up getting one of these four numbers. You can get negative 1, you get negative I, you can get positive 1, and you could also end up getting positive I as well, which is the same thing as this original one right here, okay? So write it out, do all your work, and you should be okay there, all right? Again, these are common number systems. We have the natural number system, the integers, the rational numbers, the irrational numbers, the real numbers, and even the complex numbers. Those were the number systems we'll be using throughout the course of this. All right, hope this video helps. We'll see you in the next one.